All right, here we go. The first example up there. You guys ready?
Yeah.
Now look we have been doing this all along. You know all these word problems we've been writing the equations for?
Yeah.
Or the story problems? We were writing functions, okay? We've already been doing this all year. So we just got to do, some new vocabulary and some new notation. But other than that, we've already done this. So first of all, this first one says there's a big snowfall. You're going to go around your neighborhood and shovel snow for $15 per house. All right, so what about the word per here? What operation is that? Yes, it's multiplication again. We've already done this. And then our variable here is going to be the number of houses. All right, so right here. Now you could call it H. I'm just going to call it X. So X is the number of houses. So then what would your equation look like? How much money you make would equal what?
15x.
Yeah, just 15x. It's 15 and per is multiply, right? And then this is our, so per is multiply, and then this is our variable right here again, was the number of houses, was x. So it's just 15x. So the amount of money you make, we'll call that y. I guess I don't need that color. The amount of money you make, y, is going to equal 15 times x, where x is the number of houses. Does that make sense? So that's what all that explanation is in here, all this stuff. But again, we've already done this. Okay? So you should see that this chart makes sense. If we do one house, we make $15. If we do two houses, we make $30. If we do three houses, we do 3 times 15 is $45. If we do 4 houses, we make $60. Is everybody good? Okay. Now in this example, we got to try to write an equation again. Now, again, we're gonna start calling it. We're gonna write a function. All right, but it's still just an equation. So this one we're gonna write y equals. Now, does anybody happen to see what the relationship was or is on this one? The last one was 15 times the x value. Right up here. Let me zoom back up here real quick. If you look at this one, the y value was 15 times the x value. That's why we wrote y equals 15x. Damien, what do you got on this one?
Y equals 5 times x?
It wouldn't be 5 times x, because if you did 5 times 20, that would give you 100 right here.
Right.
So what are you doing here? How do you get from, you got an x value of 15 and a y value of 3?
Divide by 5.
Yes, divide by 5. So you're trying to search for the operation. Like the first example was multiplication. This one right here, this is division. Well, it could also be addition or subtraction also. So this one right here is just, it's x divided by 5. Do you guys see that that'll work? In other words, if you take this x and plug it in right here, what do you get?
4.
Yeah, 20 divided by 5 is 4. Well, that's why you get a y value of, 4. Does that make sense? Well, then this thing right here is your function. All right? Now, the next thing we got to do is fill in these definition of independent and dependent. So do you guys see that your y depends on your x? You plug in different numbers for x, and what you get for y depends on what you plugged in. So, for example, in this one, if we plugged in 15 in for x, we get out 3 for y. If we plug 10 in for x, we get out 2 for y. So let's do this. Let's write,
So the y is dependent, the x is independent.
well, the y depends on the x. So actually, it's kind of the other way around. So your independent variable, let's write this. So your independent variable is your input, which is your x. And then your dependent variable is your output, which is y. Good. So the independent variable is your input, that's your x. Your dependent variable is your output, that's your y. Now on these next three examples, we got to decide what quantity would represent the independent variable, and which quantity would represent your dependent variable. So here's how you read these. So we can do this here. So we're going to have to figure out what our independent is. I'll just abbreviate it IND, and what your dependent is. So do the measure, so let me read this one first. A painter must measure a room before deciding how much paint to buy. So does the amount of paint depend on the measurements, or do the measurements depend on the amount of paint?
The paint depends on the measurements.
Say it again?
The paint depends on the measurements.
Yeah. Yeah, you guys would measure the room first, right? And that would determine how much paint you would buy. So the measurement is going to be the independent. So this is going to be the measurement, or the measurements of the room. And the dependent would be the amount of paint. And again, that's because the amount of paint you buy depends on the measurements. All right, and then the next one, it says the height of a candle decreases for every hour it burns. Okay, so would the time depend on the height, or would the height depend on the time?
Wait, say it again.
All right, so it says the height of a candle decreases for every hour it burns. So would the height depend on the time, or would the time depend on the height? Sid?
The height would depend on the time.
Yep, good. The height would depend on the time. So that means the independent would be the time. Or the number of hours. And the dependent would be the height. Because the height depends on the time. All right, the next one says, it's kind of cut off there, but I'll just read it. It says a vet must weigh an animal before determining the dosage of medicine, right? So then, would the amount of medicine depend on the weight, or would the weight depend on the amount of medicine?
Depend on the weight.
Neve? Yeah, the medicine depends on the weight. So how much medicine they administer depends on the weight. So that means the independent would be the weight. And the dependent would be the amount of medicine. You guys okay with that part? All right, and then we have this next little chart we got to fill in. This is just some vocabulary stuff. So we have the independent and dependent. That they filled in the first one for us there. Let me slide this down a little bit. Well, the independent is the x, and the dependent is the y. Well, you could also say the x, that's the domain, right? So the domain values are independent, and then the range values are dependent. And then you could also say the x values, those are the input. And the y values, those are the output. So all those things mean the same thing, okay? The x values, the independent variable, the domain, and the input, those are all the same. These are all the same thing, it's just vocabulary. And then over here, these are all the same. The dependent variable is y, the y values are the range, and the range or the y values are the output. So those are all the same. They all mean the same thing. And then I'm going to add one on here. I'm not sure what they wanted in this fifth spot on this chart. But right below this, it starts talking about function notation. So in function notation, how you do this is the independent is still the x, but now the dependent is called f of x. So that's the next thing, that's what we're headed to in the next part of the notes. That's called function notation. So what I want you guys to remember out of that is that y is really the same thing as f of x. So wherever you see y, you could just replace it with f of x. All that says is that y is a function of x. Well, that's because the dependent variable y is a function of the independent variable x. That's all. But don't confuse yourself or overcomplicate it at this point to say y is the same thing as f of x. So wherever I write y, I could just as well write f of x. It means the same thing. All right, so then I think we got to flip it, right? All right, so what do we got to do here? All right, so we got to write equations. Like I said, we've been doing this all along. We're just going to write them in function form now, or with function notation. So again, the word per is what?
Multiply.
That's multiply again. Now, if it said $35 per hour, or $35 for each hour, or $35 for every hour, it's the same thing. It's multiply. And then our x is the number of hours. All right, well, then we should be able to write this thing. So the amount of money we make, or the amount of money the math tutor makes, is going to be y. And it's going to be equal to what?
35.
Yeah, it's 35x. It's 35 times the number of hours. So it's just 35x. Now, I said if we want to write this in function notation now, y is the same thing as that f of x. So we could, if we want to write this in function notation, we could write it like this. F of x equals 35x. It means exactly the same thing as y equals 35x. And then you could even do something like, so you could call the number of hours, you could have called that like h, right? So if you would have called the number of hours here, if you would have called that h, instead you could have wrote like f of h equals 35h. So again, those last two cases, those are in function notation. I'd probably just go with this one right here. All right, and then we got one more of these. And again, we've been writing these all along. We just haven't been calling them functions. We've been calling them equations. So this one here, let's see, the amount that you have to pay, the total cost, is going to equal, well, you got 100, and then you got plus. Well, obviously, that's an addition, right? So you're going to add. And then this is what? Multiplication again, yeah. And then the number of months is going to be your x. All right, so what's has anybody got the equation for this one then? Dewan?
100 plus 40x.
Yeah, good. 100 plus 40x. But then they're going to ask us in the homework to write this in function notation. So you're going to write it as f of x equals that. So you're going to write f of x equals 100 plus 40x. So it's really the same thing. We were just writing an equation, but we're writing it. We're saying it's a function now, so we're writing it in function notation. All right. So then let's fill in the next blank. So I'm not sure what they want here, but I think what they want is a function is like a machine. We can put in, well, x values, but that's the same thing as our input, right? I'll write input this time. So we're going to put in our domain values or our x values or our independent variable values or our input. And we're going to get out our output. And our output, again, if you think back to that chart we filled in, our output is the same thing as the y value or the dependent variable value or the, I guess that's it. It's the output. Now these next couple, on these what you have to do is, this is in function notation, and it wants you to plug in the x values and find the y values. So let me zoom in on 7. So on 7, all they want you to do, guys, is they just want you to take -4, and they just want you to plug it in right there for x. All right, so how you're going to write this out then is you're going to write f of -4. So f of -4 equals 3 times -4 plus 2. So what would that give you?
F of -4 equals,
3 times -4 is -12 plus 2. -10.
yeah.
All right. Now remember, don't get confused by this. Remember this thing right here? This is the same thing as y, right? That's the same thing as y. And then, so what we're going to get for this one, you guys said it was f of -4 equals -10, right?
Yeah.
Well, that's just a fancy way of saying that you have this point on your graph, -4, comma, -10.
So is that the answer then? -1?
Well, they're probably going to want to, you're going to write it like this. But I'm just telling you, that's what it is. It's the same as x is -4, y is -10. So that would just be an ordered pair on your graph. And then we got to do the other one. So for the other one, you're going to plug in 7. So take 7 and plug it in right there for the x. So that one's going to say f of 7 equals 3 times 7 plus 2. So 3 times 7 is 21. 21 plus 2?
23.
Yep. So you get f of 7 equals 23. But again, that's just a fancy way of saying that's your x, that's your input, and that's your y, that's your output. All right, so we got 2 more of these to work through real quick.
Wait, so are you solving it like for the given x values, or are you solving two then?
What's that?
Like you're solving 2 problems?
Yeah, there's 2 different inputs.
Okay.
Yeah, you got 2 different, you got -4 as an input and 7 as an input, and you got to get your 2 outputs, which are -10 and 23. All right, so let's do these real quick. So these I won't explain as much, we'll just kind of write them out. So we got, the first one we need to do -2, so we're going to say g of -2 equals 1.5 times negative 2 minus 5. And so for that one, you get g of negative 2 equals, let's see, 1.5 times negative 2, that's negative 3. Negative 3 minus 5 more. Good. That's that one. I guess I could circle that. And then the other one we got to do g of 6. So we're going to do 1.5 times 6 minus 5. So 1.5 times 6, that's 9. 9 minus 5. Yep, good. So you get g of 6 equals 4. You know, and if you're not great at this part right here, we'll just type it in the calculator, all right? You can type it exactly like I've got it written right there. Should come up and say 4. And then number 9. So number 9, we got to do hold on. We got to do h of negative 12. So that's 1/3 times negative 12 plus 2. Well, what's 1/3 of negative 12?
4.
Well, negative 4. Yeah, 1/3 of 12 is 4, but it's a negative, it's a 1/3 times a negative 12, so it's got to come out negative. So it's going to be negative 4 plus 2.
Negative 2.
Yep. So we got h of negative 12 equals negative 2. And again, this is just a fancy way of saying that if you made an ordered pair out of that, that the point negative 12 comma negative 2 would be on your graph. That's all. And then the last one, we got to do h of 600. Well, that'd be 1/3 of 600 plus 2. Yeah, 1/3 of 600, that's 200. 200 plus 2 would be 202. So you would write h of 600 h of 600 equals, what did we say was 202? And again, just so you guys got it, again, this is your x. That's your y. So 600 is your input, 202 is your output. And then to wrap it up, we got to write another function. But this time the domain is restricted, okay? So this time the domain only has those 3 given values, that's all. So let's see, what can we do here? We've got, it says you're going to buy DVDs at $15 each. So what does that tell you right here? Yeah, what operation is that? Yeah, it's multiplication. So that's multiplication for sure. So then the amount of money you're going to spend on the DVDs, that's going to be y equals just 15x, right? So 15x. Where x here, that represents your number of DVDs. All right, but of course they're going to want us to write it in function notation, so let me do that. So you're going to write f of x equals 15x. So that's your function. They wanted you to write that down first, so you got that part. And then it says, on this one, they want you to write down the domain and range. Well, the number of DVDs is your x value, right? That's what I said right here. So this is your independent variable right here. This is your input. So your domain is your x values. And so the only x values we have for this one are what? Tells you up there. Yeah, 1, 2, and 3. That's your domain right there. That's your number of DVDs, that's your X values, so that's your domain. Remember, the domain means your X values. So you got to write down your domain. So you're going to go like that, and then you're going to make that little set bracket, and you're going to put in 1, 2, and 3. And then you're actually going to plug those in to find your range. So you're going to take the 1 here, and you're going to plug it in there for X. Well, I didn't want to do that. Hold on. Let's go this way, maybe. So if you plug in 1, what's 15 times 1? So then your range is going to be, if you plug in 1, you get 15. So if you plug in 2, so substitute 2 in for X, what do you get for Y?
30.
Yeah, 2 times 15 is 30. So this would be 30. And the last one would be,
40. 45.
yeah, 45. So the last one would be the 3 plugged in for X. So 15 times 3 is 45. What do you think? Good enough? And again, don't be